next lecture we'll look at one of the most amazing developments in computing, and that is the Microsoft .NET framework. A key focus of this presentation is to give some practical understanding of some of the new developments within the .NET framework, especially within .NET 3.0 and onwards. Okay, so what is it that we have and what are we looking at? Basically, we have applications which run on operating systems. These run within network operating systems, possibly within workgroups, and typically access network services. Along with this, we have file systems, distributed data storage, authentication infrastructures, and domains. To glue the whole thing together, we have communication protocols such as application protocols, transport layer protocols, and network layer ones. Increasingly, as we'll find, there is a general move away from applications running directly on operating systems because they have caused so many troubles in the past, and we're moving much more towards running inside a framework. And the framework we'll look in this presentation is the .NET framework. So one of the problems that we have currently in software is the insecurity of it. And typically that might relate to the lack of education in secure methods, the lack of thought to security in the whole design, implementation, evaluation phases, poor development environments, lack of understanding of encryption and authentication, lack of understanding of intellectual property and how to protect it, general lack of evaluation of and testing of an application, and weak integration with the operating system. Typically, applications divorce themselves from the operating system level, thus the integration between the application and the operating system is often weak. Another problem that we have is the lack of support for different types of hardware and different types of architecture. If we create a program for a PC, then the same program doesn't run on a mobile phone or an Apple Mac, and so on. There's also been a plethora of different programming languages, and once we get tied into a certain language, then we are generally stuck with that language because there are incompatibilities between one language and another. It would be almost impossible to run a Fortran program along with a Java one, and so on. There's been a general lack of security integration, in that many applications are written without security in mind. There's been poor version control of components. Typically a new application will come along and install its DLL, which writes over all the DLLs which are required by older programs. And there's generally been a lack of integration with the internet and the web. So we have what could be called as old programs or legacy programs, and as we'll see, the .NET framework tries to migrate away from these old programs to state-of-the-art ones which should be uncrashable. So generally there's a lack of robustness when it comes to these legacy programs, and they often crash and we get blue screens. They have been difficult to deploy. We can have deployments where we have hundreds or even thousands of files which are installed across the whole of the system. There's generally been poor pre-run checking of an application where the program isn't checked for the way that it will run. There's been a lack of sharing between applications, a poor integration between data sources, especially for XML databases. If we write an application, it's typically tied to one type of database implementation, and it's very difficult for us to migrate towards another one. As we'll see, the key to the future is towards an XML storage, which stores data in a neutral format. And unfortunately, there is still too much legacy code in the system. If we have one little bit of legacy code in our system, it can be that piece of code which can compromise the whole system. So let's not dwell on the past, and let's look at the future of software. Where we've been is that we've provided applications and software services. We have too often bound an application to a certain operating system, such as XP, without a thought whether it would run on Vista. We also have seen that we have large applications bring along with themselves large amounts of baggage, DLL, driver baggage. Rather than using standard drivers and standard libraries, they bring their own, which can mess up the system. Applications also can run directly on the hardware. If they run on the hardware, then they can take control of certain parts of the system, which could cause other applications and services to crash. We've had direct driver calls, which can cause programs to crash, and we also have a problem called DLL hell, where an application comes along and installs its own DLL with a new version where other applications need a different version. There's also been a binding of application programs to certain hardware architectures or certain CPUs. As we'll see, the Microsoft.NET framework tries to get away from all these problems. So what we have just now is that we typically have applications and services which run on an operating system, and then that manages them to run on the hardware. This is defined as a thick client, where applications are compiled directly for the hardware that we're using. The future is likely to be towards three different models. One is that we run software not on the operating system but inside a framework. The framework exists and is fairly standard in what it provides, so that it doesn't matter that the application is running on different types of hardware or architectures. So in this case, the services run inside this managed framework, and then it is up to the framework to bind itself to the hardware. So we'll see that this is the architecture that the .NET framework uses. Another major change is that the web browser can now provide us with almost the same interface as a normal Windows interface. So more applications are moving towards what are called a thin client, where most of the code is contained on a web server and only the interface to the application is provided. This makes security and management of the access much easier. It also divorces the software application from the hardware. Another major change is also towards running applications inside a virtual environment, which then links itself into the operating system. Again, the advantage with this is that we can create multiple images of operating systems on our hardware. Hardware has generally become more and more powerful, and software generally hasn't kept up to date with this. So we can have different types of operating systems running in a virtual image, and then isolation between each of the operating systems. This allows us to evaluate different environments and also allows us to start and stop our operating system as we require. As we'll see, the .NET 3 framework is focused on a three-layered architecture. It tries to decouple the user interface from the general business logic. This allows someone to design the interface independently from the core business services. Too much, we've designed the whole application to be integrated, and it's very difficult for us to share code across different applications. So in this case, we might have some business logic with some data services. We can put on a web interface for web, a mobile interface for a PDA, a console application interface, and then a Windows interface. It is fairly easy, if we design properly, to replace one interface with another. Then we can have shared business logic, which can be shared across applications, and we can also have a shared data storage. More and more, this part is stored as at a back end, and the user is only presented with the front end. So our code itself can be protected against copying or being changed. This is defined as a three-tiered architecture. Okay, so let's look at the future of software, and that's towards the .NET framework. Basically, the .NET framework is built around core areas such as ESP.NET for web services. There are API interfaces, and there is also a robust COM+ model for distributed components. These have now been replaced by .NET components, which hopefully are even more robust and even more optimized. The programming languages of the past, including Visual Basic for applications, and ESP, have been brought together in a new language which is completely object-oriented, called VB.NET. The old languages of C++ and C have now been integrated into C#, which again is a completely object-oriented programming language. Both, as we'll see, are fairly well coupled together in that if you read a VB.NET program, you can normally transfer it easily to C# and vice versa. These then are built to create an executable program, and we have what's called intermediate code. So it's not code that runs directly on the hardware at all, like machine code or assembly language. It runs as an intermediate way, in a general way, inside the .NET framework. It is then up to the .NET framework to produce the runtime code for the machine. As we'll see, the Visual Studio environment creates an excellent interface to create .NET programs. So we have at the core a builder, or as we could say a compiler. It doesn't compile to machine code but to an intermediate code. Then we run it inside a common language runtime, or a CLR, which is similar to a Java virtual machine. Then the .NET framework allows any language to be integrated with it, so it's not fixed to C# or VB.NET, and there is a common language specification. As long as the language conforms with this, then it can integrate with the .NET framework. So for example, you can have Fortran, and Fortran can integrate to .NET as long as the compiler writers have conformed to the standard. Linked with this is the framework class library, and this is common across all of the languages. So no matter which language is used, then we are still using the same classes, and so it is relatively easy to be able to read an application written in one language and transport it into another, because the same classes are used. A major problem in the past has been that one programming language has used one type of data storage. For example, an integer might be stored as 64 bits on a supercomputer, but only 32 bits on another, and then when we try to transfer data between the two, then we get a crash because the data formats are incompatible. So .NET tries to overcome this with a common type system where all the data types are stored in a standard format. The code that we have in between is called the Microsoft Intermediate Language, or MSIL, and it runs obviously on the framework and not directly on the hardware. So luckily we actually store the .NET framework on our systems, and we can typically have more than one version, and most computers actually have the whole range of .NET frameworks. If we see here, that we go into Windows, Microsoft.NET. Here is our framework, and we can see here that we have version 1.0, 1.1, 2.0, 3.0 and 3.5. So if we have a look in the 2 framework, we can see here that we have a whole lot of DLLs which should be protected so that no one can come along and change these, and they should be standard across all computers. So we have various core libraries here. MS Core, corelib.dll is one of the core libraries that contain much of the standard code that we need. So the application itself will bind itself to one of the .NET framework libraries. It is backwardly compatible, so that a .NET 1 or .NET 1.1 application can run within 2 and so on. So we can see here that this is an example of version 1.1 framework. 1.1 was basically when the framework was almost complete and robust, and we have here the MS Core lib, and it has many of these standard things that we would need in an application, such as arrays, file I/O, and so on. This is a protected area and shouldn't be changed by other applications. So basically what happens is that we have intermediate code. Obviously the intermediate code is much slower than compiled code for the machine, but as hardware is becoming more powerful, this is becoming less of an issue. So the intermediate code runs directly on the framework, and it should be managed so that these applications should almost be uncrashable. They cause exceptions, the exceptions can be handled, and typically these applications only crash when, or stop when, the exception isn't handled properly. So the framework manages them, makes sure that they act correctly, and then it is up to the framework to be able to convert it into machine code at runtime. Unfortunately, we also get native code which will run directly on the machine. It is often this native code which can cause many of the problems and cause the whole system to crash. So this is the conversion from intermediate code into native code. We also have a concept of the global assembly cache, and it's up to the global assembly cache to keep the DLLs that are required by applications. So in this case, this application requires version 1.2 of a DLL, this one needs version 1.1. So it is possible for us to bind the application to the specific version of the DLL that we require. It's also possible to say that an application should bind to the most recent version, and this can be defined pre-runtime. So this shows an example of the global assembly cache. We can see here that we have multiple DLLs. It is in here that DLLs are registered into the system and then can be used by any other .NET application. So as an example, we can see here that we have Office tools, we have a version number, and we typically have a unique code which uniquely defines the DLL. Again, if we have a look in the system, we should be able to see our .NET framework. And here we have the global assembly cache, and we can view all the assemblies that we have in there. And you can see here this is for .NET version 2. We have a large amount of these assemblies, Microsoft.inc, and here are all the Office tools. We can see different versions for each one, and it is here that we register our DLLs. So Visual Studio itself allows us to create many different types of applications: Windows applications, web services, web applications, mobile applications, Windows services, console applications, and so on. As we'll find, we can also create new and exciting .NET 3 applications such as Workflow, CardSpace, and the Communications Foundation. So how has it evolved? Basically 1.0 was released in January 2002, and quickly, or relatively quickly, it was updated to what is seen as a standard framework of 1.1 in April 2003. It supported new bug fixes and a compact framework. This worked extremely well for standard web applications and for standard Windows applications. Unfortunately, the website was still relatively weak. The major change came with .NET version 2. With this, we started to get enhanced web pages, such as with ASP.NET components. There was lots of new controls, 64-bit, many more bug fixes, and support for serial communications through and support for serial communications and Bluetooth. This was around November 2005 and has become almost de facto standard now for applications. Most applications will run quite happily inside a .NET 2 framework. Then Microsoft decided that they needed to develop next generation systems and analyse the main areas that required development, and this included the new way of authentication using Windows CardSpace that we'll see some demos of later, the Windows Presentation Foundation, which again will look at how we can create XML representations of animation and graphics. There was the Windows Communication Foundation, and then on to the Windows Workflow Foundation. It is these four elements which have made the .NET 3.0 framework the success that it has been. The potential of them, though, is probably untapped at this time. So basically for web applications, we started off with HTML, and we required some interaction because HTML typically just reads through a page, and we cannot get interaction such as button clicks and feedback from the user. So JavaScript was integrated with our HTML code, and this has caused many problems, typically due to incompatibilities and the loss of code. If an application has JavaScript in it, then the user can view the JavaScript because it is run on the client side. So this is a short-term fix. So JavaScript has evolved to Ajax. Ajax again is a short-term fix that allows us to send JavaScript to a client, and then for that to be processed on the client browser. The enhancement onto this was from JavaScript on to server-side scripting, where the scripts are actually run on the server and not inside the client browser. So with ASP and PHP, the ASP code and PHP code is identified between tags. The server then processes the code in between and then converts it into standard HTML. So this gets around to many of the incompatibility problems that we had with JavaScript. So the user only sees HTML code from ASP or PHP. The advantage with this is that the actual code, the integrated code, is not actually seen by the user. This code itself was fairly messy, and the development environments have typically been poor for this type of integration. Dreamweaver has never really integrated with this type of development fully. So there needs to be a way that we could develop web applications, front ends, along with back-end code. So the code behind method has been developed, and with this we create an ESPX page which contains fairly standard HTML, and then the code is triggered from that page to go to a normal C# or VB.NET code. So in this case, the code for the button click that we have on the page will run this code here. And this is a much more natural way of actually running the code. When we upload to the website, we basically only upload ASPX and the associated C# or VB.NET file. So where are we now? Basically we have been in a legacy type system with ESP, DirectX, COM components, horrible languages such as VB and C++. We are now in what's called a reduced legacy system with XP, Vista and so on, and we have improved server-side code, improved components, better frameworks, and improved object-oriented languages. But the future is towards a completely no legacy system which gets rid of many of the problems of the past. With this we go towards a code behind system with web services. We move towards XML as the way to present our graphics and our content within a framework and with enhanced languages. And we also move away from the client-based systems towards a server-based one. So let's look at the Windows Presentation Foundation and see if we can view the next generation of visual interfaces. Basically, the development process, the way that we integrate code into web pages has been extremely poor. There has been a general lack of integration of graphics, text, documents, 3D animation and so on, and we typically need plugins for different types of systems. The future is likely to be towards a complete XML infrastructure using a technology such as XAML, and for that we should be able to create applications which contain animation defined in an XML format. Then we can link to code at the back end. It is only when we have this that we'll be able to truly decouple the user interface from the back end logic. Basically we've moved from HTML and then we enhanced it with style sheets, and unfortunately they're still fairly rigid in their infrastructure. And then to fix the lack of interaction and dynamic features, we've moved on to integrating JavaScript to make web interfaces more dynamic, but this can only be seen as a short-term fix. Then the next level is on towards Flash and Flex technology, which use ActionScript 3.0 for their coding, and we get improved buttons and controls and so on through the Flex framework. But the Windows Presentation Foundation gives us much more and gives us a completely open XML infrastructure which isn't tied to any manufacturer. So the light version, or Windows Presentation Foundation E, is the Silverlight implementation and gives us a low impact method of getting the Windows Presentation Foundation into web browser applications, but the future is likely to be towards this complete WPF integration. So basically we have our Windows Presentation Framework. It integrates forms, documents, 3D animation, graphics and media, and we can find in the forms of XAML or in C# code. And basically what we have in XAML is our storyboard. It might show some animation. In this case it will change the opacity of an object from 1 to 0 in the period of 1 second. So it will disappear on the screen in 1 second. And then we can have code behind this with C# code. This shows an example of our XAML, and the great advantage of this is that file formats such as PNG and GIF and JPEG will hopefully disappear and will move towards XAML files, which are XML representations of these legacy formats. So we can use a designer if we want. So the good thing is that designers can get on with designing without having to worry about the complexities of HTML and back-end code, and they can divorce the user interface from the business logic. So in this case we can design and then it will produce the XAML code for us. So let's look at a simple example of Windows Presentation Foundation first. So we typically start a new project, and we'll start with Windows Presentation Foundation application. We can also go for a browser or for a control library, but we'll go for a standard Windows interface. What we get is our XML XAML code here, and then we get the associated C# code. We'll just make this window a little bit bigger. Here, make it wider, and we can obviously go in and change our XAML code as required. So in this case we're just changing, we can change the height and we'll change the width. So let's go for a 602 width. And what we'll do is that we'll just put in a very simple button. So we go back to our application. Between the grid we can paste our button in, and we have our first button here. We can obviously change the colour of the background and things like that, but what we'll do is we'll build it and see if our application is actually working. And we can see here that we have our first button. We can obviously change the text on the button, such as this. We can change the colour, and hopefully it should help us to pick the border colour here, change the thickness of the border, and so on. So we build, and then we can debug our application once it's built. Such as this. So let's look at designing some XAML code. So in this case we'll use Microsoft Expression Design, and we'll just create a new document, and we'll create the Scottish flag. So we'll just take a blue rectangle. We'll make it quite simple. We will want to do an extensive design, but we'll just have two lines that cut across diagonally there and there. Obviously it doesn't quite look like the flag, so we'll make it 30 pixels, and again 30 pixels, and it's not quite perfect, but it'll do. So then we'll export that. Oh, obviously we'll save it first as a design, so that we can come back to it, and then we'll export it into XAML. So we have Scotland.xaml, and we're quite happy with that. So now we'll just open up file, and this is what it looks like. So we have a canvas here which is defining our main graphic. We don't need the XML part here for our code. So what we'll do is we just paste this in now to our XAML, and we can see here that we have our graphic. Any of the elements we can actually move around if we require. We rebuild our application, and now we can debug it as required. And we can see here that we now have an application with an integrated XAML graphic. Okay, so let's look at another example where we create it as a button. So I have a pre-prepared example here just to show how easy it is to import our XML. Just have a slight problem here with some of the XML. Let me try and find it. I've pasted in grid and we've got to match up our code. So all this is that I've created a button now, and then I actually have my graphic in there. So we can rebuild the program, and we just start debugging. And this time we actually have a button with the Scottish flag. I appreciate that it doesn't look much like a flag, but obviously a graphical designer could make a much better job of that. Okay, so for the next part of this tutorial, we'll look at how we can create an event on this button that we've created. So with this, we define the click event, and then on our code we then add this method within the C# file, and it should handle the event. Okay, so what we'll do is we'll just add our event, and it's on the click event. And we'll call it button OK clicked. So then we go to our C# file. I think I've just changed the name there. So go back to our code here. Just make sure we have the right name. We rebuild that. Hopefully that should be okay. And that's fine. And then what we'll do is we'll just start the debugging. And all this should do when we click on it is that it brings up a text box, message box with hello on it. Okay, so that showed us how we can do our events. So we'll go on to something a bit more complex, and we'll look at a stack panel layout. So we'll just copy in some XAML code here. You can see how easy it is to integrate our graphics. So we can see here that we have a basic list box, and this is my menu. I'll just build that just to see if the graphical interface is working okay. And it won't actually do these links, but it should certainly show that it's working. Okay, so now we're going to add our links to it, and for this we define selected is the extension to the list box item. So we have selected equals and we'll call it web 1, and selected equals web 2, and then in our code we can add these two methods. Don't need that one anymore. So this will basically just start up a web browser for each of the selected items. So if we select Napier University, it will select web 1. If we select the other one, it selects web 2. And I just need to add this namespace. Sorry about that. Build. Okay, so we've been successful, and then what we'll do is we'll just start it. So now when I click on there, it should bring up the Napier University webpage, which is fine, good, and we're using ESPX, which is good to see, for the university. And again, we bring up the research group page, which hopefully also is built around an ESPX interface, and then we can actually exit that. So we can easily add, we can copy and paste if we want. If we want to add a new element to it, such as an exit button, an exit element, and then web 3. It's really easy to add this extra element. And let's say we just want to close the application down. Build it. Everything's fine, and we can start debugging now. So now we get our links working fine, and hopefully when we press exit, then it will exit the application. So next, let's look at another example with a docking panel. So we go back to our XAML again, and we paste in our panel here. It's just a different way of representing it. Now we have our items over here, and we obviously need to add in, we already have the code, so we just add in our selected, and it gives us all the events that we require, all the methods that are required, sorry, here, and then we can add in, say, an exit if we want. We just update that code, and that will be web 3. So our code is still the same. And then we can run it. So we can see here, there's the main site. And then we can exit. Okay, so that shows the docking panel where we can actually dock things around the page. So a similar infrastructure is to use a grid layout. So again, we can just paste in the code here. And it's web 1, and the research group is web 2. Build it again, and then we run. And I've changed the colour there to it, and it runs in the same way. Unfortunately, we don't have an exit on this one, so do that. So as before, we can change any of the properties of the system that we have. So we can see here that the colour has been changed. If I can just find it. want, we can make that a different colour, and we can obviously change the text colour and so on. Okay, so let's say we want to bind the controls that we have so that we can feed them into another form. So what we'll do is that we'll set up a grid pattern where the user can enter some details, and then we'll just display a basic text message box. So here we've created a basic user input where the user will put in their name and street and city and so on. And then what we've done is we've given each of these boxes a name. So I've called it text F and text L for the first and last name, and it's these names that actually create the controls. So we should now have a text box named text L and a text box named text F. So what we do next is we just see if we have our button created with our click event. So we don't need these anymore. Okay, we can obviously just click on our button if we want. Just reload that. It will help us generate the code. If we double click here, it will generate the code for us with the event, and we've pasted too much code in, so we just take that off and that too. So if we see what we have here, it's taken the name and it's just a standard text box that we have. So when the button is clicked, it will go to this event, then it will generate first name, second name, and then it should give us a message box with these things. If we go back here, we can actually see that the code, just by us clicking on the button for save, it's created the event routine for us. So we build it. And that's worked fine. So we now debug it. Okay, so we will go for Fred Smith, save that, and we can see here that it has managed to get the word Fred and the word Smith from the box. Okay, so now let's look at how we can define style. So in this case, we'll define a redefined label with a certain format. So you can see here we've defined label as Arial 12 and bold, and obviously when we run it, oops, we have a small problem here. Just rebuild it again. And we obviously don't have that anymore, so we can take that code out. And now we can run it. We can see here that we've created a new style. So we go back to our XAML. And now we'll have a look at storyboards. So in this case, all we're going to do is to add a button, and then we're going to change the opacity of the button from 1 to 0 over a period of 5 seconds. So we paste in there, and we just have a simple button. So we'll rebuild that. That's worked fine. So now we run the application, and we should see that it fades away after we've clicked it. So there's a 5-second change from 1 to 0. What we can then do is that we can change the storyboard. So this time we'll actually change the width of the button. So the width is currently 125 pixels. So we're going to change the width from 125 to 300 pixels over a period of 5 seconds. So we just debug. Start. So you can see here that we increase the size of the button, and we can do the same for the height. So the target property in this case is the height of the button, and we go from 40 up to 80 in a period of 5 seconds. So we'll build again, and we can then run. So normally this design would be done within inside a designer package, but we're just editing the code, the XML code. So there are many other enhancements that we can make to this. If we show here the potential of the Windows presentation format, we can see here this is an example of the kind of application that we can actually develop with a Windows presentation format. We see here the usage of the graphics is next generation and are enhanced on the way that we would normally present these applications. A strength is obviously that we can present these via any interface that we actually require. The next part of the .NET framework is the Windows Communication Foundation, and with that it is the move towards service-orientated applications. So too much in the past we've created applications which have their own DLLs and own services running locally. This is difficult to manage, so what we need is some way for applications to be able to contact services and run in a distributed manner. So the .NET 3 infrastructure defines a consumer of a service and the service itself, and this gives us the architecture of service-orientated architecture. And basically the Windows Communication Foundation brings together 4 main elements for this. Web services, where we provide a web interface for remote services. We have message queues that we can receive multiple messages. We can define places that consumers can subscribe to message queues, so that an application can just add a message and all the subscribed consumers can actually read from there. We can have distributed transactions where a transaction could be, part of it could be completed on one machine and then completed on another. And we have the new infrastructure for remoting, which is .NET remoting. Basically, .NET 3 defines ABC, where we have an address, we have a binding through a certain protocol, such as SOAP over HTTP, SOAP over TCP, and we have a contract, and that contract is the thing that exposes the service to the client. So we have endpoints, the information about the service is sent with these WSDL information, and we can have message queues, and this will be towards a completely distributed or service oriented architecture. The next area that we look at for the .NET 3 framework is Windows card space, which should give us new ways to be able to identify users much easier than with usernames and passwords. Basically what we have is we have either a personal software card or we have a managed card. With a personal card we can create these at any time. The details are encrypted and we can easily transport them between different devices. Or we can have a managed card which is associated to a digital certificate that is used to verify a user. Managed cards are useful in that we can store all the details of the machine and then we can use our card on different systems. So when we create a card, we create either a personal card or a managed one. This is an example of a managed card, a personal card, and for this we can have some just personal information along with a picture and so on. Managed cards are created by identity providers such as VeriSign, and the identity is verified by the identity provider. So with a personal card, we could use a personal card to log in. So rather than logging in with a username and password, we could just assign a card to a website, and then when we want to log in, we just pass the card to the relying party and are able to log in, and our details are uploaded. For online purchases, we might get an infrastructure such as this. The user contacts the relying party, wants to buy something. The relying party tells them what identity they are looking for and who they trust. So then the user goes to the identity provider, then gets a token, proves their identity, gets a token that can be provided to the relying party to identify them. There is no communications in this case between the identity provider and the relying party. So the infrastructure of the future is likely to be towards this. We can have an identity selector where we select our identity for a given application. We then contact the relying party, typically through a security markup language such as SAML, with inside security policies using the WS framework. And then the identity provider could work on the standard digital certificates or through the new Kerberos type infrastructure. This type of system we've seen many times. We take our passport to check-in, we then get a token from check-in, and if airline security trust check-in, then they will accept the token that we've been given. And it's this trust that we will have in the future between identity providers and relying parties. We can look at a federated structure where we can have several check-ins, and as long as the airline security trusts those check-ins, then we can have this federation and a distributed identity provider. So we see an example here of us creating a card. We select it and we can look at the complete history of the card, and then in this case we log into Windows Live using an information card rather than usernames and passwords. It asks us which one we want, we select it, then we should be able to log in successfully, and hopefully it will give us our details. An advantage of the system is that it should show the history of the card and how it's been used. So what we'll do is we'll show an example of card space code. So in this case we have set up a web server on this machine, and there is a simple example here. So the simple example for this basically just is used to log in with a certain card. So in this case we define the code in which we will go to next, and then we define that we're submitting an information card as a type, and then inside the required claims we're going to pass the given name, the surname on the card, and so on. Eventually we get a private personal identifier, email address, surname, and so on, and it's these details that we can use to log the user in. So what we'll do is that we'll see what the basic card space example is. So this should give us this layout for the design eventually. Okay, so all that we're doing here is we have a label. Once we've logged in, then the label should display the basic details of the card. So all that happens is that we take the XML token, in this case, which is the card, we get the parameters of it, and then we'll display it to the text box. So we set this up as the start page, and what we'll do is that I've preloaded it on the machine. We need typically an HTTPS connection. Okay, then we select a card, after which we can see the details of the card, such as this. So it's likely that Camtasia hasn't recorded the selection of the card there, but I can assure you that it asked for a card. So we look at the second example. So in the second example we do the same again, roughly, in that we upload a card in this case, and then once we have uploaded it, we call up the second login screen. We can see here we're doing the same for all the details on the card, so we should be able to see the first name, the surname, and so on. So this time in the second one, what we do is that we read in the card, and then we can define a token, and the token itself gives us certain claim types that we can actually take from the card. So we can get things like date of birth, country, email, gender, mobile phone, and so on. So just put it back as it was. So this will allow us to be able to show the first name, the second name, and the surname on the card. The basic user interface is this, and so once we've logged in we should be able to see the basic details. I think that should be called surname, of course. So just let me change it here. Now we go back and we go to the second example. We'll get the token, and you may not be able to see the token from here, but I select one of my tokens, and we can see here it's uploaded that. This is the SAML markup language that we can see. This has all the encryption in it and so on, and then we'll send the card to the server, and fortunately we need HTTPS in this case, and I need to set this back up again. Okay, we've re-enabled HTTPS, and what we see is, because we're just testing, we have a self-signed certificate, so obviously that is okay for testing purposes. And we go back to test our first example again, so we sign in, select our card, and then we see the details of the card. This obviously contains encrypted content. Now we go look at sample 2, so we get the token, select the token that we want, and this is what the SAML looks like, and then we'll select the card that we want to send, and you can see here it contains the basic details that we've actually given to the card. The unique ID will be something that we can actually make sure that the card that was registered is the one that has been used. So if we look back at the code that we have, so we see there that we convert the card details into a token. It will use the encryption key to be able to decrypt the information, and from that we can get the claim types from it. Okay, so that gives us an overview of how we use card space, and we can see that users in the future might find it a useful technique to log in, as we don't actually need any usernames and passwords. We can also select multiple card identifications for different login systems, and we can export onto mobile devices and so on. The last area of the .NET 3 framework is the Windows Workflow Foundation, and it's probably one of the key growth areas for the future, in that we can integrate either flow-based or state-based workflow. Basically, it brings together stateful machine workflows, sequential ones, a common workflow, and a process-orientated software development view of workflow. And it produces a useful graphical designer for us. So in this case we can have a start and an end to a sequential workflow. Then we have an activity, of which we can have a branch for a yes or a no, and then we can define the activities that we actually do here. So you can see here this is a second activity, and we have our basic events there. So let's look at an example of workflow. So we might have start and end, and we'll just do a very simple workflow where we just display a message. So we view our toolbox, and we can see we have many different controls for our workflow. So let's say that we go for a code activity, and we just open that up, and we can see here that we have our execute code, which is the method, the event which is called up. We can view the properties here, and we can see here that these are the events that we have, and code execute is what we execute when we run the program. So we just build that, and then we run it, and it's basically just a simple example to display a message hello, and it quits. In this example we'll look at sequential workflow with an if then else activity. So for this we have 3 code activities and then we have our branch. So the first code activity is basically to enter a value of I, where I is defined here, so that I will be set for this class. Then we have an if then else branch. So if we follow this route, then it will be the value is less than 5. If we follow the other route, then the value is greater than 5. For our activities, we look at our properties and we see here that we can look at our condition, and the condition in this case is if I is less than 5, and then in the other one if we look at our condition in this case, then if I is greater than 5. So let's build the project. And it's worked. So we now run it. So we can see here we can enter the value of I, so to go for 4, so the value is less than 5, which means it's been successful. And we do our other test. This time we'll test if I is greater than 5. 7, and I is greater than 5, so this is what. And this type of approach simplifies the coding, and we have a more graphical interface which should be easier to map to general workflow tasks. Now let's use expression blend to be able to create our XAML with some sort of storybook. So if we just start a new project here, and then what we'll do is we'll keep it simple. We'll just have a rectangle in which we'll animate. We will make this red, such as this, and then what we'll do is that we'll create a new timeline. Just call it timeline 1. So we can see here that we have our timeline across the bottom. What we basically do is to create keyframes in which we define the motion between one keyframe into a next. So what we'll do is that we'll record a keyframe here, which will record the rectangle at this position, and then we'll say after 1 second we move the cursor to here, and then we'll do another keyframe, and we'll move it to here. So we can see the blue dotted line shows us the path, and then we'll move it on to the second. We'll add in another keyframe, so we'll move it to here. So we can see here the movement will be from there across to here. So let's say we want to change the color of the rectangle as it goes. So let's say we make it grey. So now when we play the movie, you can see that the rectangle moves, changes colour. So this will take us 1 second to here, and then 2 seconds to here, and we can play that back, and then we can select, we can view our XAML here, and all we really need to do is to copy this code into our Visual Studio window, and everything should be fine. So we go back here, we add in our XAML, and we just refresh so that we have our animation. Hopefully we build it, hopefully we won't have any errors, and that's fine. So we start debugging, and what we should see is our animation.